All right, guys. Hey Debs is back. We're doing some more LeetCode. I have some great news today. Looking at some grades, and then these are the two problems we're going to do. We're going to do the root equals sum of children and the univalued tree. So if we go to our channel, 215. When I checked earlier today, it was at 201, and then when I checked later, and when I was looking at some comments, it was at 210. I haven't replied to a lot of the comments. I need to do that. I'll probably do that after I post this video. But I've been getting a bunch of nice comments. Like day 28 got 451 views, and day 30 got 509. Those are huge numbers for the channel. And one of the guys was suggesting, a different to my solution, and but like recursion is kind of the point of binary trees. Like we're trying to solve the problem recursively most of the time, not iteratively, because that's easier to do with trees, and that's kind of like my main goal with trees is to get better at recursion, kind of think recursively a lot of the times, unless there are problems too big that you're going to run out of stack room. But and then another guy was like, put your LinkedIn profile in the comments, which is a great idea, except I don't have it. I mean, I have a LinkedIn profile, I have nothing on the LinkedIn profile. So I'm gonna think about updating that recently, and start adding that to the description, and just a bunch of super nice comments, super nice people reaching out, and I haven't got a single hate comment, which I think is phenomenal. Been playing too much Dispatch. Phenomenal, man, almost said. But this is day 31, and it's been a long ride so far. I appreciate we hit 1K views on our first video, which I think is awesome. Anyways, just thank y'all for all the support, all the love I've been getting. A bunch of people's been reaching out saying like, good job, great job, like sharing their stories, what they're doing. And I think it's really awesome to have a channel that people can come and explain what they're doing to me. I've been thinking about making a Discord channel for fellow programmers, devs, specifically junior devs, to kind of reach out and give them footwork on trying to get into the industry, which I still haven't got into. I'm still trying to find my way into getting a job application and getting a job, actually, which is getting harder and harder as the AI industry is blowing up. There's still job opportunities, but they're getting slimmer and slimmer because the pool of people looking for jobs is getting bigger and bigger with the more layoffs. And not only is that pool getting bigger, it's also getting bigger with more experienced people that they'd rather hire than someone like me. So, but anyways, we cannot worry about that, right? This is what I think about. That is one of the external factors that we can't control. What we can control is the LeetCode problems we do, the knowledge we have in our brains, and how we use it and implement our problems. And the reason we do this is I'm hoping you think computers are cool, you think programming is cool, you're good at solving problems. I mean, that's why I'm here, because I've always loved computers. I loved how they interact with each other. I wanted to understand more. I've always like the hardware aspect when I was a child, like building computers, and now with college I get to understand the programming aspect and how all that comes together. I think it's very interesting, and that's what has driven me this far. But enough of yapping. It's been about 4 minutes of yapping, but we're going to get straight into this problem. This one's easy. This is the easiest tree problem I have seen. Roots equal sum of children. You are given the root of a binary tree that consists of exactly 3 nodes. The root, its left child, and its right child. Return true if the value of the true root is equal to the sum of the values of its children, or false otherwise. So this one is as easy as return if root.value is equal to the sum of root.left.value plus root.right.value. And that should be it, because you want 6 and 4 adds up to 10, that's equal to 10. And then 3 and 1 adds up to 4, which is not equal to 5. And if we submit this, this should be correct. I'll show the test case is accepted and submit this. I think this one's more for like, yeah. I wonder how many people have tried this problem. I think it's fairly easy. Okay, only 385,000, but the majority are accepted solutions. Yeah, this one is an easy tree problem. It's number 2000, so it's a fairly new problem, I'm pretty sure. But we're going to do problem 1000. This one's a bit different. It has an acceptance of 72. It has about the same amount of attempts. But this one's a univalued binary tree. A binary tree is univalued if every node in the tree has the same value. Given the root of a binary tree, return true if the given tree is univalued or false otherwise. So we could just return, we can make sure the root does not equal null. If it equals null, we can return false. We can just return false. I don't, will it ever give us an empty tree? Yeah, maybe not. So we can just return false. Oh, equals null. Other than that, we can go ahead and check if root dot left does not equal false, does not equal null. Okay, the little crunching sound, shadows right there, you know, little pup. He's chewing on something. I don't really know what he's chewing on. Another different thing with these problems compared to problems I've done, I did not come up with a solution beforehand. Kind of coming in here because these are easier problems. I figured I should be able to come up with a solution. But the main thing I want to do is check if the value, the value of the first is equal to the value of the left or the right, and then check that all the way down. If the value of the first is equal to the value of the left and the right. So if root dot left that's not equal null, we want to get well, we can just create a boolean for all the values. So boolean left and right. Left is equal to false, and right is equal to false. I'm trying to think of the best way to do this. Best way to do this would be to probably we could just overload this and pass the value itself to another tree, and then from there we could check. So we can do public boolean is univalued tree, and then we pass a tree node, and we call this root, and then we pass in an int value. And then from here, we want to pass check if. We probably just return if root dot value is equal to root dot. This will be the boolean right. This is equal to is unival tree. Unival tree of the root dot right, and then boolean left is equal to is unival tree root dot left, and then we can just say at the beginning if root is equal to null, that means we reach the leaf. We can just return true because I mean it's the root, it doesn't matter. And then we can return we need to pass the value, so we'd pass it root dot val and then root dot val. So what this is doing is checking each branch, and then those will return the boolean value, and then we can return if excuse me, boolean this, no, root, we'll just call it current is equal to if root.value is equal to val. I'm going to put that in parentheses just to be easier to understand. And then we want to return the current and left and right. If we can just return true for that. Well, yeah, we can just pass is unival return is unival tree. And then we pass the root and the root.val. And that should be good. And we'll go ahead and try this out. Yeah, so that runs for each of the solution: true, expected true, false, expected false. There we go, beats 100%, 0 milliseconds. So kind of the logic for this is we pass the value. We could do a couple checks and check the left and right side first, and then we can call it recursively for the left and right side to make sure its value is equal to those. But I just felt like it'd be a bit easier if we just pass the value itself we're trying to look for. Root is never going to be false, because if it is false, we return true anyways, or if it's null. And then we pass the root.val, but this root.val would cause an error if root is ever null. So I'm guessing root is never null in this. We could check that at the beginning, but I would just assume that it wasn't. And then from here, if we get to past a leaf node, then we want to be sure to return. If we get past a leaf node, we want to be sure to return true. And that way we can call root.val, root.right, root.left without worrying about root being null, because you can't call root.right on a null character, on a null root. So these have the values. So this checks the left and right side, and all it does is it will return left and right if they're null characters. You can imagine a leaf. We can build this with the epic pen. So go ahead and get epic pen out of here. And so 1 is the value here. This gets passed to every function down the line. So this has to equal 1. And then this will check the right and the left. And since these are both null characters, we implemented this right here to return true. You're acting crazy right now, buddy. I'll take you out in a little bit. Little puppies running around. I gotta take them outside. But so that will return true. So and with any true is just true, or whatever the current value is, that's what it's going to return. So then it sees if the current value is equal to the value we were passed, and this passes 1 down all the way down to the bottom. So it's making sure that 1 is equal to 1. And then since it's equal to 1, we get a true here. So then true returns true. This one points to null right here. So true, and then the current is also true. So all these are true. So then true gets passed up to here. And the same thing happens for here. It's like true and true for the nulls. True and true gets checked with 1 because 1 is equal to 1, and then true. It's just a big true or statement. And all the way at the beginning, all the way at the front, if any of these are different, if it's a different value, it will return false all the way up the line to the very first call of the of the and statements right here. And if any of them are false, it's going to return false all the way to the top. And the value that gets returned is it checks each current node. This is a recursive problem, so every node gets called with the current boolean. So it will make sure that the value that we're looking for is equal to the root that we're looking for. We would want to pass val into here. Not root.val, because you can imagine if it's the 5, then it would return a false, but everything under it would return true, and that's kind of like misleading. So the initial value needs to be passed into everything. and that should run fine and run in 0 milliseconds. But that's kind of the solution. So each node will run this line of code right here, and then every subtree will return a right or a left boolean, and at the end it will check if any value is not equal to the value we're looking for. It's going to return false for at least one of these, and so this would return false to the function call that called it. And then from there it will go all the way up to the root call, and the root call is the base function on the stack, right? And that function call return false all the way up to the this call, which is the original call for the is Univalued tree, the overloaded Univalued tree, because we passed in the value. And then that would return true to its subsequent function call. That's all I was trying to say. Runs 0 milliseconds. These were two very, very easy problems. This is one of the easiest problems I have done in a while. This one's just a sum. It's just be sure that you're able to access each element and compare it to the original element and understand what the question is asking. They're called easy problems for a reason. We are going to try to do some harder problems. I say that every video, but I might do another easy problem tomorrow. School has been kicking my ass, you could say. I haven't done much today because I've studied and done so much the past few days. But that's not true. I've done like 3 different homeworks. I've taken some notes. I took a test today, and then hung out with my girlfriend until she went to work, and I spent the next 3 hours working on schoolwork. And then now I have a few more things. I'm probably gonna work on my paper some more tonight. I have to come up with my my papers on multi-threading in Go, Java, and C++, so I have to write the code test for those. So in total, that's going to be 9 different programs I have to write for each of them. I've never multi-threaded in a programming language before, so I'm going to have to learn about multi-threading in 3 different languages, and then multi-thread in 3 different languages, and track all the metrics that I laid out for them. And then in my paper, we'll compare and contrast those metrics and how they each program performed, and then we'll be able to kind of tell which language does best for what, which is kind of like, you already kind of know which language is best for what. Like Go is good for multiple processes because of it uses user threads, and then like C++ is very good with low-level operations on the CPU because it uses CPU threads. They're more expensive to create and destroy. It doesn't do well with thousands of threads because you can't create thousands of threads because the scheduler has to swap those out, like the processes themselves out. And anyways, that's kind of out of the scope of the LeetCode problems. But I want to make this video. I really wanted to thank everyone for all of the subscribers and the likes and the comments. It's been super nice, super fun making these videos. I'm going to keep on doing it. I hope you all enjoy day 31. And like always, y'all stay healthy, stay blessed, stay coding, and Hey Devs is out.